All right, this is about the soda straw thermometer. This is one of my favorite labs, if not the favorite lab. Now the results occasionally actually do come out quite nice, but really the more care you put into it, the better the results, especially on this one. And I will say, warn you right now, that this is, although it's my favorite lab, some students find it the most frustrating. It will be done very quickly. Some groups I've seen done in a half hour, and other groups I've seen still struggling after an hour. So a lot of it takes care, and sometimes it's just the straw that's being used. You need a straw. Any straw will do. Actually, any straw where you can see through it will do. This is not the best straw to be using for this. The best ones actually I get from Waffle House, and I am saving those for the actual lab, so I don't want to waste one on now. So basically I'm taking a straw. Now, one reason I had it in the wrapper is in earlier version of this lab, I had people actually put it under the tongue, and so I wanted to keep it clean. I try not to do that anymore. I'm cutting off the end. This is a Slurpee straw, so it's got the little cup at the end. Not necessary. So, and why don't I pick that up? Because I should. All right, so trash to be dealt with. 2 pieces of trash. All right, so I have a straw right here, and I need to get water into it. Now, part of it is I get water into it, and then I need to seal the end, and that's the tricky part. So I start out with water right here, and I basically dip the straw into it. Now, as I dip the straw into it, I'm sure most of you have done this at some point, I lift it up, and you can actually see there's a line right there where the water is. If I take my finger off, it drops down. Now there's a cushion of air right here at a certain pressure, and there's air pressure underneath here. As it fills with water, when I lift it out, the water drops just slightly, creating a little less pressure. Goes back to the fact that the temperature hasn't changed, but my volume increased. What I care about is the air. The volume of the air increased, and so the pressure dropped. Because the pressure dropped, it is now at a lower pressure than the air pressure underneath, and at that point you basically have you're going to keep the water in the straw here. So as I do this, I have water in here, and let's see, do you get a better view? No, better with the white background. So I've got water right here, and I need to be able to seal it. Now if I pull it off and try to seal it right now, and at this point there's no water in the straw. So I need to basically seal it while it's still in the water. And so what I'm going to do is I'm going to wrap it over a few times. And this does require someone with some sort of manual dexterity. I wrap it over, and now it's basically sealed like that. And I want to secure it a little bit better. So I take tape. I take good, at least some quality tape here. Now, sealing the end, the students have tried various things. Some students had a great deal of success with each of these techniques. Some students have had horrible success or great failure with each of these techniques. Now, the original technique that I did when I first did this lab was just use tape. And tape can work fine. Part of the trouble is that, especially on the last part, when you stick it into the really hot water, you can't do it very long because the tape will come off. Now, the downside is if you mess up at some part of this lab, you're starting over, and that's where the frustration comes in. So right now I have tape in here. Is it sealed? Well, the water is staying into it. You can see the slight change right there. That's where the level is. The water is staying in. Now, at this point, there are a couple places that you can still mess up. Oh, the other ways. Besides tape, some students have taken a lighter and melted it. That has worked well in some cases, but if there's a tiny little crack, it's messed up. And one, I found some sort of wax or something like that to put in there to sort of seal it. You know, as with all the others, it works sometimes and it doesn't work other times. So basically, I have water in the straw. Now, the thing is, I need to turn it over. Now, if I turn it over too quickly, I'm going to sling water out of this, and I'm starting over. If I do it too slowly, then the water is going to go, basically it's going to start leveling out. I get a little air crack going, and boom, it's over. So there is that right speed. Now, I don't know if you can see how close I can get this to here. Now notice that I want this, the the meniscus right here, I want that transition to be as level as possible. If it is too slanted, then especially when I go to the boiling water, then it is going to mess up. Basically, it's going to take that as the weak point, and you're going to get an air bubble running right through it. So the more level that is, the better. So right now, it still seems to be holding its seal, and what I care about is this air column right here. I've got water right here, I got the air column right here. Now, as the temperature goes up, as the temperature increases, this air is going to expand. As air expands, some of the water is going to come out the top. That's okay. Again, I need this air column to stay sacred, to stay, well, keep its integrity. As the air inside here cools, the air is going to contract and this water level will drop. And so at this point, I need to establish room temperature because the air basically is room temperature, and I put a little mark right here. I'm taking my Sharpie and I put my mark at that level. So room temperature will be told to you, and so if the air column expands past this point right here, then I'm dealing with temperatures greater than the room temperature, and as it contracts, it should come below. Now, finding room temperature, so room temperature is easy, that'll be given to you, that's one of your data points. Another one of your data points, it's going to be either ice, if I can get some from the grill or someplace like that, or it's going to be from the drinking fountain, which is the one right down the hallway right here. It's cold water. It should be fine. If you run it too much, the water starts to warm up, but until then, you're fine. So you can go out there with a thermometer, get the temperature, the actual temperature. And so basically, you're going to end up with 3 different temperatures. You're going to end up with room temperature at this mark. You're going to end up with another temperature for cold, and then another temperature for hot. Hot is where most people mess up, where it gets messed up. It's not anything necessarily they've done. I can't point to anything and go, oh, you should have done such and such. It just sometimes that's where the most mistakes happen, or that's where basically the integrity of the thermometer breaks. So now the key thing here is let's say I put this into my mouth, I know where it's been. Now, as I did that, the air column increased slightly. Now, if I pull it out and then make a mark, well, it's already cooling as soon as I take it out of my mouth. And so the mark needs to be made while it's still in my mouth or in the water out there or in ice water or in the hot water. The mark needs to be made while it's still in whatever you're trying to measure the temperature of. Now, here's why we're doing the lab. Well, besides it's just cool. We've got a certain air column here. Now imagine that the temperature gets down to absolute zero. Absolute zero ideally is the point where nothing is moving. Now, you get into quantum physics and that's not exactly true, but in classical physics, absolute zero, no movement at all. So if you imagine all these gas molecules in here not moving, well, they'd just be clustered at the bottom, pretty much no distance. So if I know what the temperature is, if I know this length at room temperature, and the length at hot water and the length with cold water, well, I basically can set up a graph. And then I can just project it down to what happens when the length is 0. When the length is 0, that's absolute 0. And so I'm trying to figure out what temperature in Celsius happens, or centigrade for you old school people, what happens at what temperature Celsius or centigrade is the temperature, is the air column have 0 length. That's absolute 0. Now, ideally, it'll be negative 273 degrees Celsius or 0 Kelvin, and well, we'll find out what happens. To me, it's a really interesting lab. There is a time limit. I'll put it on at some point so that if you haven't finished it by a certain amount of time, then I'll tell you there's a plan B, but hopefully we don't get to that point. So that's the soda straw thermometer. Just take your time, And, you know, it really is cool when you get the group that everything works perfectly for. The groups where it doesn't, well, you're just like most people then. So, cheers.